Circles number 4. Our goals today are I can find right angles in circles by finding inscribed angles that intercept a diameter, or a radius that intersects a tangent line at the point of tangency. Our second goal is I understand that opposite angles are supplementary in all cyclic quadrilaterals. And our last goal is I can construct a line that is tangent to a given circle that passes through a given point outside of the circle. All right, so first thing here goes with our first goal. An inscribed angle that intercepts a diameter is a right angle. So as I look here at this, you look here at angle PMQ, which is right here, angle PMQ. And you learn that inscribed angles are half of the intercepted arc. So this diameter here means that arc PQ is 180 degrees, okay? So angle PMQ is inscribed in circle C, intercepts arc PQ, which is a semicircle. So this angle here is half of 180 degrees, which means that it is a right angle. So therefore angle M is half the intercept arc measure, which is 90 degrees, okay? And the other thing to look at here is a tangent line and a radius are always perpendicular if they intersect at the point of tangency. So right here, here's my tangent line QP. If it intersects a radius right there at point P, then these two lines are perpendicular, or angle CPQ is a right angle. Okay. So list all angles that are right angles. Okay. So you can tell here that this is a tangent line. Line ID is tangent because it touches circle U at one point at D. And this is clearly a radius. So we could say that this is a right angle. Let's see, same idea here. Line LP intersects circle U at one point at L, and LU is the radius. So this is a right angle. It would also make the other side right angles also because they are supplementary. And then if you look here, this angle here is inscribed angle LNB, and it intercepts a semicircle, so that this arc LB is 180, so angle LNB would be half of that. That would be 90, okay? And as I look around here, I don't really see any other right angles. So we're going to say angle IDU. We'll say the measure of angle IDU equals 90 degrees. We'll also say the measure of angle U DT is 90 degrees. The measure of angle TLU and also angle PLU. And then the last one would be angle LNB. Okay, so it looks like we have 5 right angles there in that picture. All right, the next thing is called a cyclic quadrilateral. So quadrilateral whose vertices all lie on a circle is a cyclic quadrilateral. So as I look here, this is a quadrilateral because it has 4 sides, and it's cyclic because all 4 vertices lie on the circle, okay? If you look here, all 4 of these points are on circle Q. Quadrilateral is said to be inscribed inside the circle. And then opposite angles are supplementary for all cyclic quadrilaterals. So as I look here, this angle plus this angle have to add up to 180. So 63 plus angle P equals 180. And then when you look here, angle M and angle O, so 101 plus angle O equals 180. So you could find missing angles quite easily here. Just subtract. So P equals 117. O equals 79. Okay. Or I guess you say the measure of angle P and the measure of angle O. Okay. So anytime you have a cyclic quadrilateral, the angles that are opposite. So when I say opposite, they're across from each other. Okay. These are opposite. Oops, let me use the same color here. Let me use red there. So these are opposite because they aren't next to each other. They're all the way across. Okay. Here's another one. This time you have to use a little algebra. Here's my opposite angles. This is another cyclic quadrilateral. So we're going to say 60 plus 4y plus 32. You add those two angles up and they equal 180. So let's combine the 60 and the 32. Gets me to 88. Divide by 4. I get y equals 22. Now don't put degrees because it's not a degree. It's a quantity for the variable right there. And then these two here are going to be supplementary. Notice I didn't mark them with congruency marks. I didn't put these there because that would be wrong. Okay, I'm just using colors there so that I know which ones are opposite of each other. So 94 plus x minus 12 adds up to equal 180. Combine your like terms. And I get x equals 98. Okay. All right, the last thing is constructing a tangent line. So if you were given circle O here and point P, okay, first thing you're going to do is you're going to connect your point that you're trying to draw your tangent from and your circle. So you're going to connect them, make OP. And then you're going to do a perpendicular bisector. Now this just says bisector, but it's also perpendicular. So you put your compass centered at O and open it up so that it's over halfway. So they open it to right here, make an arc, flip your compass, put the point at P, make another arc. And when those intersect, that forms the perpendicular bisector. So this would be the midpoint right here. I'll put an M there. And then once I do that, I put my compass point here and I open it up to this point. Or I open up to the center of the circle. And I really don't need this full circle. I really only need to make that arc right there and that arc. Once I have these points here, you can connect them. So you actually get two tangent lines, but you really only need one. Okay, so let's try it. So first thing I'm going to do is I'm going to draw a line connecting my point here to there. Okay. And then the next thing I have to do is I have to make a perpendicular bisector. So I'm going to open this up a little bit right there. So just a little bit over halfway. And I do that, and then I keep it the same length. I put my point over here, and I need to find where these intersect. So there we go. I can mark those 2 points. And I construct my perpendicular bisector. Okay, notice it looks like a 90 degrees, so that's awesome. So this point here is my midpoint. I'll call it M. And then I need to now move my center right there. Move my center to the midpoint, and I need to open this up so that it's the same. Whoops, I don't want to do that. Oh shoot, that's not what I want to do. Let me go back. There we go. So once I get this, I just need to find where it intersects the circle, mark these 2 points, and now I'm ready to draw my tangent. So I just connect these and check it out. It looks tangent there, and I get another tangent right there. Okay. If I label these points, I don't know, let's call it C and D, I guess. Obviously, line PD or ray PD is tangent to circle O. Okay. And also, technically, I guess we learned this earlier, OD is perpendicular to PD. Okay, because that's a radius right there. Although I don't have the radius on here, but if I were to draw it there, you can kind of tell that it sure looks perpendicular. Okay, let's try another one here. Here's O and here's P. Let's start by connecting these. Let's get a compass out here. All right, so now we need to construct a perpendicular bisector. So I need to put my point right here on the end point. I need to open this thing up over halfway, and I need to find where these intersect. I'll move this here. And when those intersect, that will form my perpendicular bisector of OP. So I'm going to draw that line. And I mark this point right here as my midpoint, call it M. All right, so now once I have that point, what I need to do is I need to put my center of my compass right there on M. And my compass needs to open up to MO, which pretty close right there. And then I need to find really just need one point, but we'll do both just for fun. Mark those points that they intersect. Call that C and that D. And then I'm going to connect point P to C. There's one tangent line and there's a second tangent line there as well. Okay. All right. Thanks for watching this video.